you know, you're going to track with it, but there's a place where you can't see it because, and you can explain why. So, okay, I'll try not to go on. But on this right section, and I'll actually do this, I'll kind of take the vitreous humor away from this. See, I'm going to scooch the retina all together and just kind of show you that I can take this whole retina out of here. Yeah? Okay, and so now we have only the choroid left. And the choroid isn't rainbow like that, but when the light hits it, it kind of turns that way. But why on this half, once I get rid of my vitreous body, which I'll just kind of, the vitreous body, it's called, or vitreous humor.
Ooh, nice.
Okay, and it's held by the, it's called the hyaloid. Oh man, this, wouldn't you know, this is hanging together so well. It's really hard to get off. Sorry, Nicole, I'm not making this easy for you to photograph, but
you're fine.
I'm trying to go a little too fast. Okay, so here, so folks, now watch when I try to do that same thing to the retina here. Okay, and let me make sure everybody's, see now, when I sort of try to scooch the retina, which I can scooch it, and of course it's ripping from its ora serrata up here, but now watch. I can't get it out of here. Why?
Because it's connected.
Because it's connected where?
The optic disc.
At the optic disc, absolutely. Yeah? Because I was able to see the optic disc, I didn't get right where it exits, but it's all on this right, or this superior hemisection. We could call it, whatever. So now, so there's not a whole lot to dissecting the eyeball, but now I'm going to kind of quiz you, and let's just see if we can learn it again as we go with the model. I'll use this little one first, and then we'll use the bigger one. Because this model is fair game. There's not a, I can do a few things on this. But okay, so we'll kind of clean up our spot here a little bit. Okay, I'll put this up here so everyone can see it. So we're clear on our 6 what are called extrinsic ocular muscles, right? 4 rectus muscles, and could you name them? Superior, inferior, medial, and lateral, and you know which way the eyeball moves for each of them. And then the 2 oblique muscles, the superior oblique and the inferior oblique. And do you know the innervation of each of those? You better. Cranial nerve 3, called the oculomotor, gets superior rectus, inferior rectus, medial rectus, and inferior oblique. But cranial nerve 4, called the trochlear, very good, gets superior oblique. Does this sound familiar to everybody? You need to know this, folks. I could put a pin on the superior oblique muscle and ask you to name the structure, but then as a bonus point, name its innervation. Yeah? And the lateral rectus is innervated by, anybody? Cranial nerve 6, called the abducens. Because when that muscle contracts, what happens to the anteriormost dot on the eyeball is it abducts. Hence the name. I mean, the naming of the cranial nerves. Yeah. So 3 cranial nerves just for what's called extrinsic ocular movement. Now there's some intrinsic muscles in the eye. Yeah. Do you know what extrinsic versus intrinsic means? Extrinsic muscles mean muscles that have their origin outside of the eyeball. They're extrinsic, but they insert onto the oculus. So anything extrinsic means that at least it has part of its component outside of that object. Yeah? But intrinsic muscles start and stop all within the oculus itself. And so the intrinsic muscles are the muscles of the iris, which we're going to go over, and the ciliary muscle. Those are smooth muscles, folks. So, okay, so that's as much as the external as we did. So this little model comes apart in this way, that we're able to now lift off the top of the sclera. And what was that clear part called? Cornea. Very good. So we're taking that off. And now what is it that we see when we remove the outer fibrous tunic with its cornea and sclera? We see the, and I'll give you a hint, folks, the artist has drawn blood vessels here. So that brown is the middle vascular tunic called the choroid, the iris, and in this case the iris doesn't remove, so I'm going to get this larger model just to kind of show you, because they can only do so much on one model. And the lacrimal gland I'm not holding before, although that's where it sits, by the way, so that the tears can wash over and then collect in the lacrimal apparatus and drain down into your nose under the inferior nasal concha. So what we're doing in this particular one, instead of an interior ball, this one under the sclera shows the kind of the reddish choroid there, and then the bright orange retina. Yeah. So we'll come back to this in just a second. But here's the iris in this one. And folks, you need to know this. The iris is not only the colored portion, and folks, the darker brown your eyes are, the more melanin. So light brown, or what are called hazel eyes, doesn't have a lot of melanin. But blue eyes are the lack of melanin. And violet and gray, and that's the lack of melanin. So what you're seeing as blue color is not a blue pigment. It's the lack of the brown pigment. So the generic eye color is a real dark brown because the melanocytes distributed and are producing melanin, and you've got nice dark brown eyes.
That's why babies only have blue eyes, because they're
Babies all have blue eye. Well, it depends on if they're full term. They've started that melanin is maturing. But very good point. Thank you for saying that.
Devin,
thank you. I'm going to call you Odom. I'm going to call you Odom. Sorry, I do the last name first thing. That's my way my brain works. Devin, thank you for saying that, because so anyway, in points of interest. But it's what's on the reverse of your iris, folks. That's really important. Two of the sets of intrinsic muscles, they're called circular fibers. If here's the iris. And of course, what's that hole in the middle called?
Pupil.
The pupil. It's kind of on the reverse, although you can see through a person's iris if they have light enough eyes. It's hard to see at real dark eyes, but there's a series of muscle fascicles that run circularly, and they are called the circular fibers, or collectively, they're referred to as the pupillary constrictor, and Latin is constrictor pupillaris, but anyway, yeah? Because it's a sphincter muscle, so can you imagine the nerve action potential that arrives? Again, this is from parasympathetic. What cranial nerves carry parasympathetic outflow, folks? Remember, craniosacral, part of the nervous system. Oh, you got to know this. What are the only nerves that that can initiate parasympathetic outflow, folks? Cranial nerves 3, 7, 9, and 10, or way down here, S2, 3, 4. Well, I hope you know that it's not these that are going to innervate these smooth. This is smooth muscle, folks. You don't have voluntary control over this. So I hope you know that the parasympathetic outflow arrives. Actually, constriction is, sorry, I'm messing this up. Constriction is sympathetic. So hang on. Let me explain the muscle fibers first, and then we'll do the innervation. So the circular fibers are known as the pupillary constrictor, and then there's a set of radial fibers, fascicles, that run this way, like spokes of a wheel. And when they are innervated, they are the pupil dilators. So they're called the radial fibers or fascicles, whatever, aka collectively called the pupillary dilator pupillaris. So that's what's being shown on this iris, folks. You can see they've kind of shown the coloration. But if you go behind, you can see that the radial fibers, and then kind of in between and underneath them, the circular fibers. So it turns out that pupillary dilation is parasympathetic. I'm sorry, this is parasympathetic. No. Pupillary constriction is parasympathetic. I'm sorry, now I'll get this right. Now I'm mixing matching colors, but parasympathetic, which comes from cranial nerve 3. And pupillary dilation, when you want to really see things, this is sympathetic, which comes from cord levels T1 through L2, but has to ascend up in the cord to the superior cervical ganglion. You remember I kind of tried to help you realize that on this model, we have a superior cervical ganglion. Its synapses there, and then there's what's called the otic ganglion up in the, actually, no, it's called the ciliary ganglion, up in the head, which is considered a terminal ganglia for the parasympathetic nervous system. Yeah, but for the sympathetic nervous system. Because remember, the sympathetic has to have two motor neurons, so the first one gets into the trunk, go from T1 to L2, ascends up in the trunk, unsynapsed to the superior cervical ganglia, synapses there, and then the second motor neuron goes from there to the what's called the ciliary ganglia up near in the orbit, and that's its, you know, where the neuromuscular junction is with the smooth muscle radial fibers that dilate the pupil. And when you're sympathetically innervated, you want to get the most light into your eyeballs as possible to get the most, because it's fear or, you know, energy expenditure, and like if you're exercising, you need to be aware of your surroundings so you don't trip and fall and do things. So